Hi everyone, welcome back to my channel. So today we are going to talk about derivative. Alright. So before I talk about derivative, I want to talk to you about two concepts, okay? So the first concept will be slope. Okay. So the first thing that um, you should know about slope, okay? So what is slope? So slope So as you know, slope basically change of y over change of x. So rise over run, right? The formula for slope is this: y2 minus y1 divided by x2 minus x1. So that's the slope formula, okay? So what does that mean? So it basically means, if you know, it basically means this. If you know 2 points, let's call it x1, y1, and let's call this point x2, y2. Okay, this is our x-axis, this is our y-axis, this is the origin. So the idea is simple. If you know 2 points, you can easily compute the slope. So y2 minus y1 divided by x2 minus x1. All right. So one more thing. Instead of writing y1, right, we can actually write f of x1. Okay. Instead of writing y2, we can write f of x2. Why we can do that? Because remember, our y is equal to f of x, right? So in this case, instead of writing y2, we can write f of x2 minus f of x1 divided by x2 minus x1. Okay. So these two equations are saying the same thing. Okay. I hope everything makes sense. All right, let's take a look at the second concept. Okay, so we are done with slope change of y over change of x. This is our slope formula. The next concept is limit. Okay, so what is limit? Okay, I will try my best to explain. So think of it this way: if you have a function like this, f of x equal to x squared. If you know the input value, let's say someone says x is equal to 2, you can actually compute the y value. Okay. So that's going to be, f of 2 will be 2 squared, which is equal to 4, right? Now, limit is trying to say the same thing. Okay, so let's say limit when x is approaching 2, f of x equal to what? So limit is trying to say the same thing. It's trying to say, as x approaches 2, what's the value of f of 2? Okay, as x approaches 2, what's the value of f of 2? Since the function that we are dealing with is a really simple and straightforward function, we don't have to do much work, we can just plug it in. So that's going to be equal to 4. Okay, So again, for this specific problem, we can just plug it in. All right. So limit basically says as x approaches to 2, what's the value of f of 2? Again, it depends on this number, okay? It depends on this number. Okay, I don't want to confuse you. Let me give you one more example. Let's say we're dealing with the same function. What would happen if we had limit x approaches 0, f of 0, okay? Then again, what does it say? It says as x approaches zero, what's the value of f of 0? Okay, so in this case, again, we are dealing with a really simple, straightforward function. So one thing we can do, we can just plug it in. So 0 square is going to be equal to 0 for this specific problem. Okay, now it seems like you all are ready for derivative. Okay, let's take a look. So the first question is, what is derivative? So think of derivative like slope. Okay, so we want to find out slope of a curve at a specific point. Okay, now you may be wondering why we call it derivative, why not slope? Because when we talk about slope, we basically talk about straight lines. Okay, so when you have straight lines, the slope is always going to be constant. But if I'm dealing with a curve like this, the slope is constantly changing. The slope is not constant. Okay, so the slope is constantly changing. So let's say I want to find out the slope of this curve at this specific point. Okay, so how can I find out slope of this curve at this specific point? All right, so you may be wondering, well, if you want to calculate the slope, you need actually 2 points. All right, so let's do that. I only have 1 point, so I need 1 more point, right? So what I'm going to do, I'm going to choose a point that is really close to this point. Okay, but I'm not going to draw it here because I don't want to confuse you. I want to draw it here. Okay, but think of these 2 points that are really close to each other. Okay, so these 2 points are really close to each other. All right, so we got 2 points. Now we got 2 points. Now we can find out the slope. Okay, so let me call it x. Okay, let me call it x. So this height, let's call it y. So this point will be x comma y, right? Makes sense? Okay, let's say this distance is equal to h. Okay, let me use a different color. So let's say this distance is h. Okay, I should not have used this color. All right, so okay, so this distance is h. So this point will be x plus h, isn't it? So this point, so from this point to this point represent x, from this point to this point represent h. All right, so if this point is x plus h, the height will be x plus h comma you know what, let's call it y1. Okay, let's call it y1, and I'm going to call it y2. Okay, now if you remember from the slope section, okay, if you remember in this section we actually talked about y1 and y2. So instead of writing y1, you can write f of x sub 1. Instead of writing y2, you can write f of x sub 2, right? So we can apply the same idea. Instead of writing y1, I can write f of x, okay? Instead of writing y2, I can write, so x plus h comma f of x plus h, okay? I hope you see the pattern, okay? X, f of x, x plus h, f of x plus h, okay? So it represents the y value. Okay, let me use a different color. So this part represent the y value, okay? So this part represent the y value, okay? All right, so once I have 2 points, I can actually, so I hope it makes some sense. So now let me give you the derivative definition, okay? And I hope it will make some sense. So the limit definition of the derivative says the limit definition of the derivative says f prime of x will be equal to limit as h approaches 0 f of x plus h minus f of x over h. Okay, so the limit definition of the derivative says f prime of x is equal to limit h approaches 0 f of x plus h minus f of x over h. Okay, so now let's take a look. Okay, so at this point we still have 2 questions. What does this part mean? What does this part mean? And how did you get this piece, h, right? So this part, okay, before I explain this part, let's talk about this piece. How did I get h? So take a look here. You have 2 points, right? If you have 2 points, you can actually find out the slope, right? So what's going to be the slope? So what's going to be the slope? The slope is going to be change of y, f of x plus h minus f of x, and change of x, which is x plus h minus x. Okay, so that's going to be f of x plus h minus f of x divided by, well, this x cancel each other out, h. So this portion is basically talking about the slope of this. So think of it, if we had a straight line, if we draw a straight line connecting those 2 points, we can actually find out the slope of this line using this formula, right? All right, so I hope now it makes some sense. So again, the idea is simple, okay? So the derivative gives us the slope. So this represent, so the derivative gives us the slope. So this represent the slope at a specific point, right? Why at a specific point? Because as we already talked about, the distance between these 2 points will be approximately equal to 0, okay? That's what it means, the distance between those 2 points. So those 2 points kind of behave like a same point, okay?